Brad King, CTO of Scality. Welcome to the Data Exchange podcast.
Thank you very much. Glad to be here.
So, Brad, obviously, we're in the AI, machine learning, data age. So, someone like you could work on many aspects of these things, right? So why storage?
So we didn't come into the world of storage because of AI, machine learning. We really came into it because our customers were struggling. One of our earliest customers was doing huge volumes of email, and they just asked us to do something, to do a stuff store. And we thought that was a pretty interesting idea, store lots of stuff. And I think storage volumes.
So roughly what year was this?
This was about 2007, 2008, when one of our customers asked us if we could start looking at storage. So Scality actually exists officially since about 2010.
So not quite HDFS yet.
No. So that's all been very interesting because when we first started, Amazon S3 did exist. Right. And so our platform was an object storage, a software-defined object storage platform. And that made a lot of sense for many, many use cases. It certainly made sense for usages that we were seeing at the time. And HDFS was doing HDFS, right? So it was a distributed system that was all kind of growing at the same time. And I would say things like AWS's EMR, Elastic Map Reduce, created a way for us to use object storage together with Hadoop and replacing local storage on platforms. And that was something that we didn't develop ourselves. We did a lot of looking into it, but it was in the end, it was AWS that provided us the opportunity to use object storage.
So the early use cases had nothing to do with analytics and machine learning?
Fundamentally not. Our very first use case was massive email systems, and we still have a number of those. We have customers that have hundreds of billions of emails on our platform. Of course, a lot of the people that are storing those emails are doing machine learning on that data. But the main drivers were things like massive email storage platforms, also giant backup platforms. Then we started including things more like logs, video assets, and then the whole world of doing digitization of all kinds of data. Libraries were doing that kind of things. And then one of the things that we started seeing that's very complementary is people like the automotive industry storing sensor data from automobiles that they were using for improving not quite yet self-driving cars, but certainly driver assist kinds of things, collision avoidance algorithms, lane guiding algorithms, things like that. So you have all this sensor data that was being stored, and then they could run their algorithms against those pools of data to determine if their algorithms were getting better, if anomalies were being detected and things like that. So that's a whole world of big data. And you had, people like the software Salesforce people that said data is too cheap to even throw it out. So you get these giant pools of data, and everybody's trying to figure out how to make intelligent decisions based on their data. So those kind of things made it so that people started being more hesitant to throw out data and wanting to have larger and larger pools of data. And keeping your data all in one place really made a lot of sense. Having a single namespace became a really hot topic in the early days of Scality because people were tired of having silos and silos. And when your data pool grows and grows, you get more and more silos.
So for listeners who don't follow this area closely, most people interact or use storage systems somehow. So in my mind, so this is a bit naive, Brad, but there's three buckets, right? So there's the object storage, there's the distributed file systems like HDFS, and then I guess databases. So how should someone think about all these three things?
Yeah, clearly there's what we would refer to, at least Scality and a certain number of people refer to as structured data. So indeed, databases,
Right.
data that's very clearly structured, and then unstructured data. Those are kind of maybe two categories. And unstructured data being logs, media assets, PDF files, whatever. So those two categories, and then indeed in the unstructured data category, there's two ways of accessing and storing the data, two data models. There's the file system model and a hierarchical tree structure, and then there's the object model, which is a flat a bucket, and I list my object. And the file system space has a whole set of really sophisticated rules that we refer to as the POSIX file system, that made it very hard for really large systems to grow and grow and grow. So we do both. We do the distributed file system.
Yeah, like HDFS had all these kind of limitations, right?
Right.
Like this number of files and
right, and that's been a classic problem with traditional file systems. Is they have the inode, which is this random number that nobody sees, that gives the file its unique identifier, and very often file systems would struggle when they got into the millions and tens of millions of files on a file system. So you had to think very carefully when you have a file system: are my files too small? And because if I have too many files on my file system, then maybe my system isn't full, but I'm out of space to add more files. So we've done a lot of work on those kinds of topics to make sure that both small and large chunks of data can be handled by the same system. But another one of the challenges that HDFS had was it was a distributed system, which is great. There's a lot of goodness that comes with that, but it was also shared on the same servers as your compute was. So
right.
you kind of tied up to scale the system, right? I mean, the story used to be one core, one disk. Was kind of the numbers that they used to give us. But we talked to banks that would say, well, we need 20 cores per disk, and other people that say we need one disk for exactly the opposite, one CPU processor and 20 disks. It depended so much on your workload if you were doing very sophisticated data analytics, or if you were doing very simple things.
So a CTO or CIO or a data architect these days, so they want to grow their storage infrastructure. So what are some key criteria or even trends like multi-cloud? So what are some key considerations now as you're evaluating options for growing your storage infrastructure?
Yeah, I think there are definitely a lot of things that are being talked about. One of them is having all your data in one place. We refer to a single namespace, but there's a lot that goes into that. One of those is being able to have a single interface to your data, and that interface being usable by many different applications. And the interface of choice these days is becoming more and more an API-based interface. Typically Amazon S3 interface, because a get, put, and delete interface has all kinds of advantages because it's WAN friendly, and multiple applications can share the same set of data. And that's always been a problem. You have all this data that you want to store, and you maybe have the application that's creating the data, and then you have an AI or machine learning application that wants access to the data, and you only want to give it read-only access. But you have these traditional file system interfaces that involve quite a bit of sophistication. So object storage, that's one of the trends, is being able to share data kind of on a whole spectrum of usage that may or may not be simple to manage. You have some of the data that's become publicly available, open data, and having data that's been created government money is paid for the data. So people say, well, we should have access to this data. That sounds good, but we don't want any Tom, Dick, or Harry to be able to just delete my data. So you some of your data, you need it to be publicly accessible. Some of your data is very closely guarded. And so you have this whole panoply of things. And then I think one of the things that we're seeing, certainly in Europe, and I think in the US, we'll see it more and more, the GDPR, all the work that's been done to provide safeguards for data to say, if I, as a user, want my data to be gotten rid of, somehow you have to know where that is, and I can get rid of it. But then data sovereignty, what country should my data be in? And I think those are things that are probably a lot more pertinent right now in Europe than they are in North America. But everyone is thinking, I put my
But is
data in the
that
public cloud.
so, Brad? What you described there in the GDPR, is that more at the application layer, or is that something that you would expect the storage people to take care of for you?
Well, so one of the things that I think metadata would be another topic I would add there. Having metadata that travels with your data is becoming more and more important. And for the GDPR kind of thing, who does this piece of data belong to? Does it have an owner? Is there a user that this is associated with, so that I could find, using metadata, all the data that belongs to John Smith. And when John Smith decides he wants his data out of there, how do you know it's John Smith's data? Well, metadata can help in a situation like that. So that's one of them. But I think indeed it's typically applications that have to manage those kind of things, but they need tools. And you just have a giant file system, with maybe 10. Typically every piece of data on a file system doesn't have an owner that's actually the person that the data belongs to. So metadata can help out a lot in that world. So I think that's one of the things we're definitely seeing, is people are becoming more and more cautious and realizing that I really need metadata to travel with my data.
So is the reality more especially as you go to larger companies, is the reality really and I think this is the case for anything that in IT for a large company, that there's no monolithic or single system. They have a variety of things that they're using. So is that true also in storage?
So I think there's a desire to have more and more a unified interface to a giant pool of storage. But indeed, the variety of applications that are using the storage is growing more and more, and in having the store that's available for a map reduce kind of a solution, or a machine learning solution that's doing
and also
very
just
sophisticated GPUs.
The nature of a company, there's many groups. Some groups move faster than others, right? So,
and this silo notion is something that people would love to get rid of, because people spend a lot of time managing access rights, managing who has access to what. And then you have this famous problem with storage systems, that I've got one system here that's 95% full, and the other one that's brand new, it's completely empty. And it becomes a management nightmare. Just so if you've got this notion, I think the public clouds have really encouraged this notion. I just have an API. I say, store my data, and when I want it back, I want it back. And I don't know anymore who's taking care of my data. And we're having quite a few of our customers are providing, their IT departments are actually providing those solutions inside the company, so that developers don't need to think about storage. They don't need to put in a purchase order and say, I need 10 terabytes more storage. Please give me 10 terabytes. You just use the storage. It really becomes a service. And I think we'll see that more and more.
By the way, I think you folks are well positioned for this increasingly multi-cloud world, right? Because basically you provide companies this object store, but then the API of the object store is a familiar S3 API, and yet you're not tied to just one cloud platform.
Right. And as a matter of fact, we started our initial value proposition. We told people we have the technology and the scalability that a public cloud offers. We use the same kinds of methods of distributed systems to provide that, but you have it on premises, so you have the security and all those protections. But more and more, we're seeing people opening up to public clouds. And then the question has become, well, can you help me on my journey? I may have some storage on premises today. I want to start using a public cloud and see how that works. I don't want to be tied to just one public cloud. So we've developed interfaces, and we just announced a new product called Artesca that allows us to, you can push data to AWS, you can push it to Google Cloud, you can push it to Azure, and it's kind of a multilingual multi-cloud system that protects your investment, and so you're not tied to a single cloud.
By the way, the Artesca, what's interesting about it, as I saw it, is it's something that actually hadn't occurred to me. But the chief marketing officer, they have Salesforce, right? So, or something, they have a dashboard, but IT people don't really have this big picture view of what's happening, right?
Exactly.
This Artesca actually does a good job of that, right? So,
and we have this dashboard that we really like to talk about with people, where I have multiple places that my data is, and they can be replicating between them, but I have a single view, and that may, for some customers, that could be literally tens of petabytes of storage. Some of it's on premises, some of it's in one public cloud. I can verify that it's being replicated successfully. I can verify that my data is being protected well, and I can also open up access to it or do searches across it and treat multiple destinations for my data all as a single space, in a sense. And additionally, we're moving more and more in the direction of providing classes of storage, so that you have an object store that's fast and even maybe on flash, which is a trend in the industry, because flash is becoming more and more economical, and people find that really low latency access to object storage is pretty interesting. So maybe you don't want all your data on flash, but you're going to have it on different tiers of storage and life cycle it and all those kinds of things. So I think that's what we're trying to provide, all those interfaces, managing your data across them.
So what's the state of, so in the structured data world, as we mentioned, so there's databases. So what is the state of, what's the best thing that you've seen in the unstructured world?
The best thing, I think,
as far as, for example, video or audio, and images. Yeah.
I think one of the key things that we're seeing here is that you make the two worlds live together. You have the structured data that allows you to have fast searches. The media industry have what they call media asset managers. So it used to be that you had a media asset manager and you had all of your data on tape. So all of a sudden, if you want a file, you have to wait. And now now your data is right there. And I think from a human progress perspective, maybe one of the coolest things is the medical industry. It used to be that a doctor would require the patient to bring back their X-ray films and things like that. And now they can have a whole patient history right there, right now, if they're in an operating room. And so those kinds of things are interesting. And then in the AI world, we're starting to look at things like digital pathology, where you could actually have electron microscope data, and then you can start to think about identifying cancerous cells, or being able to automate some of that work, and then have some of the rest of it done by really true experts. And I find that very fascinating in that industry. Historically, people are shipping glass slides around the world for doctors to learn how to identify pathologies. So I think we're going to see some really cool things in the medical industry.
Yeah. And in the machine learning and AI world, actually, one of the hot topics is multimodal models. So meaning, you build a model, it may use images, but it may use structured data as well.
Right.
Like you can imagine a recommendation system or a prediction system that uses both structured data and unstructured data. So it does make sense to have a storage system that allows you to just get both types of data, or all the types of data you need to build your model, right?
Right, and we have, you see the machine learning world also, the mixed modes between what was traditional data warehousing, and so very structured data put together with Hadoop-like big data analytics, and we're seeing a lot of companies like Splunk index data on very fast storage, and then the rest of the data is available on a pool of data like a Scality, so that you can work with both things and do the really fine-grained things in a database, and then another kind of analysis. So I think that's absolutely. Another thing we're seeing that I think is very interesting is you take this is the metadata question again, but you have a video that you stored. You have a whole collection of videos that you stored. Sometimes that data just sits there and nobody knows what it is. You can now push some of that data to a public cloud. Somebody like an Azure has excellent algorithms, AI tools to tag the data, and the famous "this is a cat," this kind of a thing. But you can also identify languages. You can do speech to text. So you can put scripts, and then you can search that text. So the model is very interesting because we can help the customers push data to a public cloud, generate the metadata, store the metadata in Artesca, and then just throw out the data in the public cloud and not pay the egress fees of the public cloud. And then you have this pool of big chunks of data with associated metadata that can be searched.
By the way, speaking of metadata, a friend of mine, Asaf Araki of Intel Capital, and I wrote a post about metadata, and one of the things that we posited was that metadata will become kind of this foundational layer, as you alluded to, right? So in other words, if you have this great metadata management system, then you can imagine building things like data catalog, data discovery, and so on and so forth. So is that something that you folks are seeing as well? Because that seems like the right foundation for a lot of these services, right?
Right. I mean, we definitely are strong believers in storing metadata, and I think one of the functionalities of Artesca that is somewhat absent in a typical AWS S3 platform, you can list your objects, but you can't search the metadata. And now they're developing a new functionality.
And by the way, in a company like Lyft, for example, before they had their metadata management system, or after they, before or after, I forget, but basically they discovered that 40% of the time the data scientists spent was just looking for data.
Oh, I'm not at all surprised. The challenge that we see, and I don't know how we're going to resolve that, and probably Scality is not well positioned to resolve that, but what's the metadata model? And I know that there's been efforts that have been put out. We've worked with some partners in the media space trying to come up with a standard model for metadata, but you meet all kinds of resistance because everybody has done a lot of work individually coming up with ways to do things. I mentioned media asset management systems, and they tend to have a metadata model, something of a hierarchical model. And so you run into these challenges of how do you make a standard metadata model that works for all data. And I think that's probably too high of a bar for the Holy Grail to have a metadata model that works for everything. But could there be industry metadata models? Maybe, but we're trying to make. We use the standard set of metadata offerings that an AWS platform has, which allows you to have quite a bit of tagging. We find that still people are really struggling to get there, even to have even limited tagging. But once they do, it's very, very powerful because you can find all the data that came from a certain country that came. We have.
So is it kind of a push or pull? In other words, do you guys have to? Does it automatically just tell you that something's changed, or do you have to probe it?
So the main time that metadata comes into existence and becomes interesting is when you store your data and you put metadata with it when the data is brand new,
right?
Because you know more about it. And I think that's one of the things that we're starting to see is companies are requiring people that store new pieces of data to associate metadata with it. And that's we had a very interesting discussion with a customer recently that commented that they were going to require their employees to associate metadata because of the fact that 2 years from now, you have a whole set of data that nobody knows what it was. And the person that stored the data left the company and nobody knows what the data is. And then it becomes really problematic. And you can use, AI tools, obviously, to solve some of those problems. but I think the discipline of the metadata is something that's not mature yet. So you have the models that are struggling, the discipline, and it's kind of a new thing to have in the object storage created. That was the idea that metadata and data live together. It's historically been true that you had a database that had maybe external blobs, but then you have to be very careful to keep everything synchronized. And that, the splitting, when your metadata becomes disconnected from your data, unsynchronized, you're in all kinds of trouble. So having them all live together and having the same protection is I think, a really key thing here.
So, Brad, what about open, as in open source or open file format? Because I know, for example, that in my area of data science and data engineering, Apache Parquet, for example, is a popular open. So what's the Scality's position?
So we've done some experimenting with it. I think Parquet is a very interesting model. Again, it takes discipline. You have to store your data, and the S3 and Parquet work very well together. So storing data in a column object format is a very intelligent thing to do, and we've done some work with that and believe it's a very good approach. And object storage is well adapted to using those kinds of approaches. And I think it's much more interesting than a zip file, because you can do queries directly on the file, and we're seeing
there's a lot of tools that work with it, right? So,
absolutely. Yeah. And I think you're going to see more and more the world of Kubernetes and the world of Lambda functions, where you have some kind of a functionality that it's like a filter. Data comes in, I make decisions, maybe data goes out, maybe an answer comes out. Those things are very well adapted to things like Parquet formats, like open data formats, and also for API-based interfaces, because you don't have to bolt it onto a file system, and you can have short-lived microservices that access all the data via an API. So I think the combination of metadata, API, and these data formats that intelligently store data is one of the trends we're going to be seeing in big data analytics, for sure.
And in terms of is there like a universal object stores consortium or OP standard? Like how do you all I guess you all build your own thing and just target S3 API, or
so that's very problematic, because in a sense, every cloud provider wants to be compatible. At the same time, they want their own unique special features. And we have definitely done a lot of work. We actually have the Azure Blob Store protocol is one that we support, but it's quite a bit different. And sometimes the subtleties of things like versioning and what metadata you can store become very painful differences between these models. And I don't really know what the answer for is that. I think the horse is out of the stable with S3. I don't expect.
So that's the API that people will target.
So that tends to be the API that people that are doing software development will target first, and afterwards they do some of the others. So we've done a lot of work to make sure that we can translate from the S3 API to the others, so you're not locked into the one. We do have we're an active.
You're locked into the API, but that's it.
Yeah, exactly. Not necessarily the platform behind. One of the things we're working on right now, which is a standard that I think is helpful, but it doesn't solve world hunger at all either, is there's a new standard called COSI, so Cloud Object Storage Interface in the Kubernetes world, which will allow you to mint credentials right into a microservice that's running on a Kubernetes cluster.
Who's behind it?
So that's I believe that's the Linux Foundation,
okay.
But in the Kubernetes,
it's CNCF,
and those people. So we're trying to be an active player in that space, but that isn't the protocol. That's just the way you get your credentials shared, the way you share the access.
I see.
So I don't see there's not a magic bullet to make everybody do the same protocol. Everybody's kind of fond of their special things that they develop that make their storage special, you know. So you know, the standards like POSIX or, you know, NFS,
NFS, yeah.
but VX or something like that, you know, and it's a little bit like SMB. I mean, SMB is a Microsoft protocol, and so people
Yeah, you want so
emulate it. Yeah.
you know the idea that you just kind of mount something somewhere and then it's there, right?
Right, exactly. And there was an attempt at a standard that was called CDMI that SNIA developed, and SNIA has been relatively successful with some things. I think CDMI was too complex, and it tried to maintain both the object world and the file system world kind of in an interesting coexistence. It's a pretty sophisticated protocol, and we actually support it, but we see very little usage of that protocol today.
So I wrote a post last year where I basically looked at, I don't know, like 8 different surveys asking question about multi-cloud. And every survey was overwhelming. Most companies are multi-cloud. Is this true? Is this what you're hearing?
It is definitely what we're hearing. I would say most of the customers that we're working with are typically working with one.
By the way, multi-cloud, let's define as that might include on-prem as one of the clouds.
Right.
Yeah. But it, yeah, all these surveys say, Brad, like I think the minimum was like 80%.
I know all the same surveys, and Alan, I would say the vast majority of our customers are doing multi-cloud in the sense that at least on-prem and one public cloud, and very often they're trying a second one. I think we see that a lot of our customers do a lot of work to make sure that their security procedures are up to speed.
So you then you are the universal storage system that they talk to. So if I work in one of these companies where they're using 2 public clouds and 1 on-prem, I don't even know where the data is. I'm just a data scientist.
That can
using
be the
Scality,
case.
right?
That can definitely be the case, and that's the value.
Which is basically this trend of. So, by the way, this multi-cloud is interesting because one of the implications, unfortunately, for the cloud platforms, is a commoditization of the cloud, right? Because basically, because if the cloud just becomes storage and compute, then I'm just going to mix and match clouds, right?
Right. Well, and you see all of the public clouds working very hard to not become commoditized. I think they saw the telecommunications industry, right?
Yeah.
And so they have very rich AI kinds of functionalities that they're working on, and they have the resources. You know, AI is hard. Data scientists are not cheap, and so you have we have. I think a really interesting example is one of our customers that has a lot of media assets that they want to do speech to text. And so they send the media asset to AWS, they send it to Google, they send it to Azure, they get results back, and they can compare the results, figure out who's doing well. They can even contact.
But that's only possible because they're using a storage that allows them to do that, right?
Right. To kind of a one-to-many writing of their data. And that's an interesting usage because you maybe push a big video to a public cloud, and then you just bring back a small text file. So the business.
Oh yeah. So it sounds So it seems like one of the main. Yeah. So one of the building blocks for multi-cloud is multi-cloud storage, really, right?
And well, you know that I think one of the things I talk to people about, compute. You can move it from A to B very, very quickly. Right. Some things are very hard to move, but storage. Well, you know, I mean, they work very hard.
Expensive to move, right?
Expensive to move storage. You know, we're dealing very often with customers that have more than a petabyte of data. Moving a petabyte of data from one place to another is not.
That's a physical FedEx.
Yeah, it's not a finger snapping experience. The fastest way to do it, you know, the best bandwidth you can get is a FedEx truck, just like you said. And obviously AWS is caught into that. You know, they can drive a semi truck up to a customer. You plug in, you put your data in the truck, and we'll take care of it. We'll ship it back. They figured that out. That was kind of one of the bottlenecks. But I think that's one of the interesting problems we see is a customer will decide, okay, we want to do public cloud. They start putting stuff in a public cloud. 2 years later, they go, it's too expensive. We don't like some of the services. So we want to bring it back on-prem. Okay, now we've got the fees associated with pulling it out, but we've also got over a petabyte of data in the public cloud.
Actually, you bring up another point, which is basically cloud is cheap in the beginning, and
Right.
then it just basically starts adding up, right?
And people, they all want you to try this service, try this service. The list of services that the public clouds provide is dazzling, and they're great services. But once you become connected to some of those services, it's like, how do I live? You use something like the Spanner database at Google. They invent these things that nobody on the world can do because nobody can pay for atomic clocks. So you get these crazy things that they're capable of doing that you could never repeat. And so we're definitely seeing in this multi-cloud space, our customers are going carefully to not choose services that are too sophisticated that you can't change.
Managed services that are just available in that one cloud platform.
At the same time, you lose out on some really powerful things. So it's a tricky game to play.
Yeah. So one of the things that actually is interesting that you folks talk about, which I've also have thought about in the past, is this notion of, I don't know if the right word is forever, but you use the phrase digital generations to come.
Right.
Yeah.
Digital footprint kind of thing. Yeah.
And so, because basically, a lot of this are basically our assets for that you want to live forever in some ways, right?
Right. And I think we on a personal basis, we kind of get that. I think everyone kind of enjoys these things when your photo storage service says, remember 10 years ago, and you're like, wow, I certainly don't want to lose that photo from 10 years ago. There's that notion of it. But I think there's also the notion that's very much a truism in the AI big data space, is that much of the data that's being stored, we talk about this being the new gold, but it's irreplaceable. And I used the example earlier of the automobile industry and this sensor data. But sometimes the sensor data represents 1 million miles of automobiles, the collecting automobiles data. If you lose that data, it can't be reproduced. And so you have these pools of data, and then historical weather data or usage data. And
historians 80 years from now will want to.
Exactly. And I think that's curation of data is a topic we talk about, just like we curate, famous works of art and things like that. But I think it becomes a tricky topic because you can fall over into the world where you've stored so much stuff. We've probably all even done that each privately, that we stored so much stuff on our computer, we can't find what we need anymore. At the same time, who wants to delete, those family photos? I've got 2 copies of a family photo. Deleting one of those copies is just a scary thing. So I think better data management is one of them, but also having storage models, and we work very hard on protection schemes that you will guarantee that your data stays around and doesn't get lost. Because the idea that 20, 30 years from now, I don't want my data to just fall off the edge of the earth. And when I go to read it, it says the 404, data not found.
Or how many of us have stored things in devices that we no longer have the ability to.
Right. And that's probably a whole fascinating topic. VHS is going the way of the dodo bird, and CD and DVD formats. The people in the optical space claim that they have the longest lifespan of a media, which I think is an interesting thought. But the tools to be able to read the media, I have a 9mm tape that I was written many years ago, and there's very few machines in the world that can even read my tape today, and probably the data would just peel off the Mylar when I go to try and use it.
So closing topic here. One trend that I'm fascinated with is security and privacy. So in the area of secure computation, one thing that people are starting to use more and more of are these hardware enclaves.
Hmm.
And but just generally, security and privacy, is that a layer above what you guys have to think about that someone else is?
So yes and no.
Yeah.
We definitely are seeing growing demand for encrypted data encrypted at rest from a security perspective. But I think also what we're seeing a lot of AWS, I think very intelligently came out with a add-on to their technology called Object Lock. And that allows you to lock an object and say, I've stored this object for the next 3 months, 6 months, no one can delete it. So it's a very interesting approach. It can be used for compliance and things like that, but it's being used very actively today in the backup space to, I do a backup to an object platform, which is a very common way of doing backups today. The target of my backup is an object platform. And I have a 3-month lock on that data so that if someone ransomwares my data, encrypts it, I have 3 months of data that they cannot touch.
I
And
see.
and
But
ransomware people
is
have gotten
this,
so,
what is the
yeah.
status of this? This is a proposal or
No,
real?
no, this is happening today, and it's becoming a very popular approach because ransomware people have gotten clever enough to encrypt people's backups before they encrypt the active data, so that by the time the company says, okay, here's the ransom you have to pay, and they go, well, we were careful about our backups, we'll use our backups. Well, the backups got encrypted too, and that's ransomware is the everyone's IT nightmare.
Yeah.
And so that's one of the things we're looking at that a lot today, is what can we do to help with ransomware, to detect it, but also to protect against it. And this object lock is one of the very simple, straightforward approaches that says for 6 months, for instance, nobody can touch this piece of data.
So we talked a lot about storage software. Are there any trends on hardware that affect storage that we should
Oh,
be aware of? Yeah.
absolutely. I think obviously all of the new, there's the world of flash, QLC flash becoming more economical. The 3D flash is a very interesting area. To going along with that, the NVMe interfaces that have multiplied.
What's so how economical is that? I mean, in terms of, can you store everything?
So we're still not the point where QLC kind of flash or some kind of flash is less expensive than spinning disks. I think is quite a ways out there, but for certain applications, it just makes more sense. The structured data, it's been a long time now that
Right.
people just don't store databases on spinning disks anymore.
Right.
And I think that day will probably come. The reliability is higher, the interface speeds are higher, but there's still quite a few issues with it. And the other area that's it's been a painful birthing process, but things like 3D crosspoint and non-volatile,
Oh yeah.
basically non-volatile RAM
Right.
is very interesting because you're never too fast, and so we have databases, indexes, and things like that we would love to run on storage like that. So I think that's a trend that you'll definitely see. And then network interfaces, your network is, we're seeing more and more. When we got started, gigabit Ethernet was kind of the staple today. 10 gigabit is the staple, but we're seeing more and more that 25 and 100 gigabit are important. And it's really been great the way, because we're a software technology, we just rise with the tide. We don't have to develop those technologies just come along. But I do think the storage is one of those things where it's never too fast. No one ever complains that your storage is too fast, and networks are never too fast. And
Especially if you're mirroring across continents, right?
exactly. I mean, we have a customer doing data analytics work on pools of data where they're writing a petabyte a day of data. And so they have like a 15-day circular buffer, but a petabyte of data a day is big amounts of data transferring through the interfaces, and it keeps their infrastructure very busy. So we're seeing the need for faster and faster network interfaces. There's never enough, in a sense.
So when are we going to have a a blockchain object store? Huh?
Yeah, there's the IPFS, the interplanetary file system that kind of does that. I think some things about blockchain are going to become little by little more a part of storage platforms. Being able to prove that a piece of data hasn't been modified, prove its origins, things like that.
Hopefully not the speed of
indeed.
their throughput. I mean, yeah.
I think we'll only see those kinds of things for a certain subset of the data, because it's indeed, I don't think blockchain is ever going to reach the speeds that we need to have sub-millisecond transactions with blockchains. But what do I know?
And with that, thank you, Brad.
Pleasure.